So write down next topic, thermodynamics and KTG, kinetic theory of gases. Okay, listen. So like thermodynamics, it is the combination of the thermal properties of matter, that is heat, then work energy, power and laws of motion. So we can divide this terms, thermo like it is the properties of heat, and dynamics it is the work, energy and power and laws of motion. Okay, it is the combination of these three lessons. So in this, like we are going to talk particularly about the heat and the work. So heat it is the property of the mechanical work. Okay, mechanical work, like if we do some work, obviously the heat energy will be produced, right now. So I can say that work is directly proportional to the heat. So from this we can write that as W is equals to J into H. So where J is nothing but proportionality, constant of proportionality, it is Joule's law. So work done is directly proportional to heat. In terms of law, if we talk, it is Joule's law. Okay, write down the topic, first topic, you can copy down this one. So J is nothing but constant of proportionality. The value of J is 4.2 joules per calorie. 4.2 joules per calorie. Okay. So this is Joule's law. So work done is directly proportional to heat. So now what are the terms we have talked in work energy power about work? So work is nothing but force into displacement, work is nothing but change in kinetic energy, work is nothing but mgh, that is potential energy, right now. So kinetic energy is nothing but half mv square, potential energy is mgh, and one more thing is work is nothing but force into displacement. So can I write W is equals to force into displacement, and it is half mv square, or else I can write this is a change in kinetic energy and then mgh. So I can write this as a work. Then what is the things we have learned about the heat in the last chapter? So delta Q is nothing but mc delta T, and delta Q is nothing but m into L. So H in terms of delta Q we have learned in the last chapter, which is nothing but mc delta T or m into L. So this is for heat. So when we are using this mc delta T, when the temperature rises, when we are using this ml, when the state is changes. Okay. So these are the things about the Joule's law. Now we will talk about the applications. Suppose a body is dropped from the height h, how much change in temperature they are asking. Okay. A body is dropped from the height h, which is nothing but height will be there and g will be there, no. So can I say like mgh is equals to the work done is equals to, so change in like temperature they are asking na, change in temperature means which formula I should use, mc delta T. So J into mc delta T. Change in state I can use that m into L. So I can cancel these two terms na. So GH will be equals to J into C delta T, where change in temperature will be GH by J into C. This is my change in temperature when a body is falling from the height h. Okay. Suppose they are saying that a body is moving with velocity v. Okay. So body is moving with velocity v in the sense work done will be half mv square. Okay. Body is moving with velocity v and they have not mentioned about change in state. They have simply mentioned about the body is moving with velocity. Then work done will be equals to J into h, which is nothing but half mv square is equals to J into mc delta T. So here also m will get cancelled off. Then half v square will be equals to Jc delta T. So change in temperature will be v square by 2 into Jc. So this is for when a body is moving with velocity v, and this is for object is falling from the height h. Suppose they are telling that object is falling from height h and it has been rebounded back to height h2. This is h1 and this is h2. Okay. So in this mg h1 minus mg h2 will be equals to, again they are asking change in temperature. Change in temperature in the sense mc delta T into J. So I can cancel this m. So gh1 minus gh2 equals to J into C delta T. So delta T will be equals to, so G times of h1 minus h2 by J into C. And now they are saying that object is moving with velocity v1 and it has been changed to velocity v2. Okay. Object is moving with velocity v1, now it has been changed to velocity v2. Then change in kinetic energy, no, of m v1 square minus of m v2 square is equals to J into mc delta T. So from this also can I get the value of delta T, no? Okay. Now the condition is object is falling from the height h. Okay. Let me take ice cube is falling from height h, and after falling, no, it has been completely melted. Okay. Then what will be the equation? Completely melted. Should I take mc delta T or m into L? First to complete this one, then I will tell the applications one by one. So any doubt up to this point? Anyone? Okay. Write down the application point. Application 1. When a mass m is dropped from height h, when a mass m is dropped from height h, then find the change in temperature. So this is the first application. Completed? Application 2 is when a mass m is falling from height h1, and rebounds back to height h2 then find the change in temperature. So this is the application. Second application. Completed? Application 3. When a mass m is moving with velocity v, then find the change in temperature. Then find the change in temperature. You can take down the formula. Completed? Write down. Next application. When a mass m is changes its velocity from v1 to v2, changes its velocity from v1 to v2. When a mass m is changes its velocity from v1 to v2, then find change in temperature. Take this formula. Completed? The next application. When a mass m in bracket you can take down ice is falling from height h, comma, after falling it completely melts down. After falling it completely melts down. Then so the formula will be mgh will be equals to j into m into L. Okay. Write down. What happened? Okay. Now the question is, listen. So 1 kg of ice I have taken, it is falling from height h, and after falling it completely melt down. I need to find what is the height of the object it is falling. Okay. So which formula I need to use here? G into H. Okay, I can use this formula, right? So GH will be equals to J into L. Okay, fine. So I need to find H, right? So H will be equals to J times L by G. Okay. Here what are the terms I know? 1 liter, huh? Okay, gravity we know. Then what about L? What about L I am asking? Latent heat? Vaporization? Two things I have given, no? Latent heat of fusion and latent heat of vaporization. What I told yesterday, like they might not give any data about the value of L, but depends upon the question. I need to understand what value of L I need to take. Either I should take as 80 or else 540. When I should take 80, like solid to liquid. When I to take 540, liquid to gas. So now what happens here? Solid to liquid. How much they have given? 80 calories, na? So 80 calories, 4.2 divide by 10. Then that's it. Get the value now. Calculation. 80 calories only they have given. 80 calories per gram, no? Then convert that into kg. Per gram in the sense kg. 1 gram equals to how many kg? 10 power. Find it. See, this is 80 calories per gram, no? I have converted this calorie into joules. So the joule already there, no? If we are converting anything into joules, no, then the value of joules I need to consider as 1, because I have converted this into joules. Okay, so now everything is in SI unit. If everything is SI unit, no, then take the value of J is 1. If it is not, then multiplied. Okay, so 4.2 into 10 power minus 3, because 10 power minus 3 per gram, no, per kg I need to take it. Find the answer. Hmm? 420. 420 is the wrong answer. How you will get 420? 4.2 into 8. How you will get 420? 30? 37 point? 10 power 3, Any one. 33.6 into 10 power 3. Once again check the calculation. Check the calculation. Whoever got 37 point something, no? Check the calculation. What happened? There is correct answer. Whoever got the 37 point something, no? Check the answer. So we will get 33600 kilometer. Okay. Yes. Yes. Tell. It will go up, no? 0, 0 cancelled. Okay. Write on the next application. When a bullet of mass m, when a bullet of mass m is fired into a metallic slab, of mass ms. So mb is the bullet of mass m, bullet of mass, and ms is the slab mass. Then find the change in temperature. Okay. So fired in the sense, like obviously it will go with some velocity v, right? So of mb v square, and should be equals to j times, and it's a metallic slab, no? ms c delta t. This is my formula. So bullet is going and hitting the metallic slab, and the temperature changes happens, like rise in temperature will be taken place. The next question is, the next application is, when a bullet of mass m is fired and penetrates into the metallic slab of mass m, comma, the temperature of both increases. Then so of mb v square should be equals to j times of mb c delta t plus ms c delta t, like both temperature increases, no? So obviously I need to talk about the bullet also, I need to talk about the slab also. Take down. Completed. The next application is, so listen, So bullet is fired, and after penetrating, like the bullet is completely melts down and the slab temperature is increasing. So what will be the formula? Like bullet is going into the slab, so bullet is completely melt down, okay, melts down, and the second point what they are saying is slab temperature is increasing. So one is melting down, one is increasing, then what will be the formula? Of MBV square equals to J times MBL plus MSC delta T. Any doubt in this point? Write the application now. Bullet is melting down and slab temperature is increasing. Bullet is melting down and slab temperature is increasing. Then write on the formula. Right on the next topic, Zeroth Law of Thermodynamics. Zeroth Law of Thermodynamics. System A and B are thermally equilibrium with the system C, then I can say that A and B are also in equilibrium. Okay, write down first point. Two system A and B are in thermal equilibrium with system C. Then A and B are also in thermal equilibrium. So what is the meaning of adiabatic and diathermic? Adiabatic. What is diathermic then? Adiabatic wall and diathermic wall. I mean, sorry, like adiabatic no heat exchange and diathermic will be heat exchange. Adiabatic there is no heat exchange. Diathermic heat exchange takes place. Right on the next topic, first law of thermodynamics. First law of thermodynamics. Q is equals to delta U plus delta W. Delta Q is equals to delta U plus delta W. So what is delta Q? Heat. Okay. U is internal energy and W is work done. So delta Q is amount of heat, delta U is internal energy, delta W is work done. And conventions, first point for delta Q. So heat is supplied to the system. Heat is supplied to the system. In bracket you can write down it is a heating of the object, heat is supplied to the system, then it is positive, equals to positive, you can write equals to positive. Next point is heat is removed from the system, heat is removed from the system. So in bracket you can take down it is a cooling, which is negative, equals to negative. Delta U, now delta U, temperature of the system increases positive, temperature of the system decreases negative. Next one is delta W. Work done by the system is positive, work done on the system is negative. Yeah. I will give PYQ now. Okay. Write down the next point under the delta W. Clockwise is positive, anti-clockwise is negative. Clockwise is positive, anti-clockwise is negative. Okay. Write down the equation. Write down the equation. 60 calories of heat is 60 calories of heat is supplied. 60 calories of heat is 60 calories of heat is supplied in the system. 60 calories of heat is supplied in the system when 40 joules of work is done on the gas, then find delta U, that is internal energy, then find delta U. Okay. Now try this question. What are the things they have given here? Delta Q they have given, delta W they have given, Q how much they have given? 60 calories. So convert it into joules. So 60 into 4.2. And what about the delta W? It is by the gas or on the gas? On the gas. It is negative or positive? Negative. Do it and tell the answer. 292 is the answer. So anyone is not getting here? 4.2. Okay, right on the next topic. Internal energy. Internal energy. So under this we are going to talk about two gases. One is ideal gas and one is real gas. So we'll talk about ideal gas in terms of only kinetic energy. Write down. So ideal gas only due to kinetic energy. Ideal gas is only due to kinetic energy. So real gas is both kinetic energy plus potential energy. So under ideal gas, one more point, no particles to particle interaction. No particles to particles interaction. No particles to particle interaction. Example, a gas filled in balloon. A gas filled in balloon, in bracket helium, a gas filled in balloon. Next point, there is no force of attraction, there is no force of attraction, there is no force of attraction or repulsion between the particles, there is no force of attraction or repulsion between the particles, that is why there is no potential energy. That is why there is no potential energy. So, next is under real gas. So, both the kinetic energy and potential energy takes place because of significant intermolecular force, because of significant intermolecular force between the gases, because of significant intermolecular force between the gases. Example, oxygen, hydrogen, oxygen and hydrogen. Interaction between the particles. Okay. Now write down the points. So, ideal gas and real gas completed. Okay. Now, the points under the internal energy. The first point is delta U is always depends upon the temperature. Delta U is depends on the temperature. Delta U is depends on the temperature. So, under that E is equals to 3 by 2 K T. Have you seen this equation? In chemistry? No. Okay. So, E is equals to 3 by 2 K times T. So, K is nothing but Boltzmann constant. Boltzmann constant. Boltzmann constant. Boltzmann. Boltzmann constant. The next point, delta U is state dependent. Delta U is state dependent. Keep a hyphen. Keep a hyphen. Only depends on initial and final state of gas. Initial and final state of gas. So, like from initial point to final point I can go in 3 paths, either 1, 2, 3, okay. But when I talk about the internal energy, no, it is only depends on the initial point and the final point. So, how much it will be? 20 minus 10 is 10 joules. Whatever the path I am taking, the internal energy will be always 10 joules. You can take that. So we are talking about the internal energy, no, and heat is also a kind of energy. Can I write the equation like this? Du will be equals to m Cv delta T. So Cv is nothing but it's for isochoric process. What is isochoric? Volume is concentration. Take down. Du is equals to mCv delta T. So Cv is nothing but for isochoric process. Isochoric process. Okay. So listen here. There is a question. I told that the initial and final point, it depends on the initial and final point. Now if I talk about the cyclic process, then what will be the internal energy? For cyclic process, what will be the internal energy? Okay. So delta U will be equals to 0. Then according to first law of thermodynamics, if U is equals to 0, what will be the equation? Write down. So whenever they are giving the equation, it's a cyclic process. So delta U will be 0. Write down properly, like for the cyclic process, delta U is equals to 0. Then Q will be equals to W. Okay, listen. The next one is work done. So internal energy is completed, no? The next point, subheading is work done. So like since we are talking about the gas, no, we'll talk the force in terms of pressure. So pressure is nothing but force by area. So force will be equals to pressure into area. Okay, fine. So what is the work done formula? F is equals to, sorry, W is equals to F dot, okay, S or X, whatever it is. So for small work done, small displacement will be there. Correct, no? So can I write the force in terms of pressure and area here? F dot, sorry, P dot A into ds. So this is dW. So what is this combinedly is called as? Area and the displacement x. Area length. So dW will be equals to P times of dV. Correct, na? Area into length is nothing but volume. So dV. So this is the formula for the work done. So in the problem point of view, if volume is changing from V1 to V2, then 0 to W dW will be equals to P dot V1 to V2 dV. Getting the point? Like work done initially will be 0 at V1 and work done will be W at V2. So dot into dV. I will write it clearly. This one will be equals to integral of P dot dV V1 to V2. So can I write this equation in terms of W is equals to integral V1 to V2 P dot dV? Again I can expand this equation, which is nothing but W is equals to P V2 minus V1, the change in volume. Take the equations. first right up to this one. Completed. So the first application 1, copy down this one. So once you have completed, no, let me know, I will give a problem based on this now. Write down the question. Application 1, copy down this one I told. For 1 mole of ideal gas, pressure varies as P is equals to pressure varies as P is equals to alpha by V square. Alpha by V square, where alpha is constant, where alpha is constant, where alpha is constant, then find the work done, from V to 2V, find the work done from V to 2V. This is the equation. Get the answer first. V to 2V. First I need to take the equation of P, need to substitute in this equation. So alpha by V square dot dV. Next what is the thing? Integration 1 by V square. So take this V square to the numerator, V power minus 2. So x power n, it is nothing but x power n plus 1 by n plus 1. Then apply the limits, upper limit minus lower limits. Ever see, alpha is constant, take out the alpha, keep it aside, only like integrate 1 by V square, that's it. Completed? What is the answer? Alpha by 2V is the answer. Only alpha by 2V. Alpha by 2V. Minus alpha or alpha? I am asking you. Then check, someone got alpha by 2V and some got minus alpha by 2V. Check it properly. Okay, listen, I'll do this. So they have given that pressure is equals to alpha by V square and volume is changing from V to 2V. So work done will be equals to integral V to 2V alpha by V square dot dV. So alpha is constant, I can take it out. So alpha integral from V to 2V V power minus 2 dot dV. So integration of this, what I will get? So alpha into V power minus 2 plus 1 by minus 2 plus 1 V to 2V. Then I can take this minus commonly outside now. Minus 2 plus 1, minus 1 will come now. So I will take it out. So it is minus alpha, it is V power minus 1 from V to 2V. So minus alpha into 1 by 2V minus 1 by V. Correct now? 1 by 2V minus 1 by V. I have taken this V power minus 1 as 1 by V. Now I have taken the 2V and taken the V. Upper limit minus lower limit. So minus alpha, this V also I can take it commonly outside. 1 by 2 minus 1, it is minus 1 by 2. And minus 1 by 2, no, minus alpha by V times of minus 1 by 2, minus and minus So alpha by 2V is the answer. So second application is P dot delta V. Third application is if V is equals to constant, work done will be 0. If P is equals to constant, work done is not equals to 0. This they might ask in the theoretical question, okay. And fourth one is PV is equals to nRT. So in terms of PV I can substitute work done is equals to nRT, okay. And one more thing, like we have talked in work energy and power, no, like the area under force and displacement graph will give work done. Similarly, the area under pressure and volume will give work done. The next application, application 5 now. Application 5, area under area under PV graph, that is pressure and volume graph, PV graph gives work done. Area under PV graph gives work done. Okay. So in this graph, no, like a cyclic process will be there, like either it is a clockwise or anti-clockwise. Take down. Clockwise will be positive, anti-clockwise will be negative. Work done for clockwise will be positive, work done of anti-clockwise will be negative. See, listen, the graph might be looking like this. For example, if I talk the graph, this one. So they have given like this. So if I find the area for the triangle, na, I can get the work done. But whether it is a positive work done or negative work done, it is depends upon the cycle in which direction they have taken place. So it is a clockwise, no, so it is positive. Suppose if the graph is looking like this circle, okay, so what will be the work done? Okay, negative. What is the work done? It is R. What is the work done now? Area under the graph, area of the circle, 4 pi r, pi r square, okay, pi r square. Positive or negative? Negative. It is anti-clockwise or clockwise? Then negative, no? This one? This is volume V1, this is volume V2. Volume is changing, na? ఏంటి మేడం ఏం చేస్తున్నారు? గాల్లోనే రంగులు వేస్తున్నారా ఏంటి? సెకండ్ వన్, ఇట్స్ యాంటీ క్లాక్ వైస్, నో, సెకండ్ వన్. ఎలా సార్? Okay. So now I will give some graph, try to identify the work done, okay. Pressure, volume, this is pressure and this is volume. Pressure, volume, pressure and this is volume. P1, P2, V1, V2, V1, V2 and this is P1, P2. Okay. Identify the work done. So first one, what will be the work done? Negative work done. Correct? Is volume is changing or it is constant? Then volume is constant means what will be the work done? Then who told negative? Positive, sir. It is 0, sir. What about the second one? Positive. Okay. If it is positive, why positive? If it is negative, why negative? Which is anti-clockwise. Here anti-clockwise and clockwise, it is not a use of these two terms. One is expansion, one is compression. When expansion takes place, like volume is increasing, na, here V1 to V2, this is X graph, no? Positive graph, no? Graph is increasing, no? Then volume is increasing, no? Then work done will be positive. Okay. And here It is decreasing. Work done will be? What about here? 0. Volume is constant in the first and fourth graph, and it is positive, and this is negative because it is compression, I mean expansion, and this is compression takes place. Take. Okay, done, no? Okay, listen, and you were having doubt, no, like it is a cyclic process, how to consider that is, like you told, like work done will be 0. So cyclic process, one thing we know that delta U will be 0. Okay, I'll talk about the work done now. Suppose this is my circle. If they are asking about the work done, either it is a positive or negative, leave about that. Now they have given the arrow mark, we will consider that is a positive. What is the area of the circle here? Pi r square, right? No, so this is one diameter and this is other diameter, correct na? If I talk about this point, this is my P1, this is my P2. If I talk about this one, V1, V2. So diameter, if I divide by 2, will I get radius? Yes or no? So W will be equals to pi times what is V2 minus V1 by 2. One radius, P2 minus P1 by 2. Other radius, pi r into r. So pi r square. Now it is 0. No, right? Now I will give one more question. This is a rectangle. This is volume and this is pressure. This is V1, V2, P1, P2. So what will be the work done for this one? Tell. What is the area of the rectangle? L into B. So what will be the work done? P2 minus P1 into V2 minus V1. That's it. So one is length and one is breadth. So length V2 minus V1 into P2 minus P1. Okay. So this will be the work done. So positive or negative, it is depends upon the like the direction. Okay. Any doubt here? Take down. And what will be the triangle? For triangle, in terms of pressure and volume, this is P1, P2, V1, V2. So work done will be of Okay, V2 minus V1 into P2 minus P1. Okay, this is fine. Then we talk about semicircle. What will be the thing? Semicircle. Think. First you complete this one and think about the semicircle. Complete this. First three things complete. Completed? No, sir. So those who have completed, no? Tell me the formula for the semicircle. 1 by 2? Okay, pi r square. Then in terms of pressure and volume I am asking. 1 by 2 into pi into P2 V2 minus V1 by 2 into how P2 minus P1 by 2. Here this is P2, I mean P1 and this is P2, no? Only radius only I am considering, no? I am not considering the diameter, no? So P2 minus P1 into V2 minus V2, I mean V2 minus V1 by 2 will come into pi by 2. I'll clear it. Listen. Wait, I'll complete this one. This is P1, no? And this is P2. This is V1, this is V2. Is this diameter or radius? This is radius. So work done will be equals to pi r square is formula for circle, divide by 2 is semicircle. So pi by 2 I will keep it as it is. One radius P1, P2, no? So P2 minus P1. Other radius V2 minus V1 by 2, no? So V2 minus V1 by 2. That's it. Getting? This is already, it's a radius only. If it is a circle, divide by 2. If it is a radius, only radius I need to consider. Think about the problem point of view. Don't memorize the formula. Okay? Like don't memorize this kind of formulas. Try to apply what is the formula there. So I will stop up to this. We will continue in the next class.